Generated by motion of molten iron in Earth's core, the magnetic field protects our planet from cosmic radiations and from the charged particles emitted by our sun and galaxy. The magnetic field also protects the water in our atmosphere from being swept away by the solar wind. It also provides the basis for navigation with compass. Yes. So students, today's video is made on simple phenomena of magnetism, electromagnetism, and applications of electromagnets. So this video consists of two parts. The first part, we will discuss magnetism. That is, we will understand that magnets repel and attract the other magnet. In the same way, it attracts the magnetic substances. And we describe the property of magnetically hard and soft materials. We understand the term magnetic field lines. We understand the magnetism is induced in some material when they are placed in magnetic field. And also we will describe the experiment to investigate the magnetic field pattern from a permanent bar magnet and that between two bar magnets. In the same way, we will discuss how to use two permanent magnets to produce a uniform magnetic field pattern. The second part consists of electromagnetism. We will understand that an electric current in a conductor produces a magnetic field around it. And we also describe the construction of electromagnet. We will discuss the functioning of electric bell and different components like we will study about solenoid, we will study about relay, etc., and circuit breaker. So magnets and magnetic material. Magnet attracts objects made of magnetic material. So these are the magnets shown. Usually the red color shows north and the gray color shows south. Magnet has two poles, north and south. And magnetic material include iron, nickel, cobalt, and steel. Why the names north and south poles are given? Because the north pole of the magnet, whenever it is suspended freely, indicates the geographical north. That is why it is used for navigation. So hard and soft magnetic material. Permanent magnets are made of magnetically hard material such as steel. These materials retain their magnetism once they are magnetized. It means this is difficult to magnetize them, but once they are become a magnet, they will retain their magnetism. And soft materials such as iron, they are easy to magnetize, but they lose their magnetism easily. So they are suitable for temporary magnet like the core of an electromagnet. The magnetic poles are parts of magnet that exert the greatest force. Okay, the strength of the magnet is greatest at the two ends. We call them north and south poles. The more iron filings are attracted towards the poles. Why poles are called north and south? A magnet suspended freely so that it can rotate horizontally will eventually settle down with one pole facing the north and the other pole shows the south pole. So this is the pole is therefore called north seeking pole and shortened to just north pole. The magnet has been oriented by Earth's magnetic field. So this is the compass and this compass, the magnetic compass is showing north and the magnet is also showing geographical north. The law of magnets. There are two magnets. What happens when they are brought close? They repel and move apart. So these are two similar poles. North and north, when they are brought close to each other, they repel each other. In the same way, two south and south poles will also repel each other. What happens when one north pole is brought close to a south pole? they attract and move towards each other. In the same way, two south and north, north and south attract, south and north also attract. So, what is the law of magnetism? Magnets, like poles repel, unlike poles attract. Magnetic field. What is magnetic field? It is a volume of space where magnetic force is exerted on magnets, magnetic materials, and moving charges. Okay, so in magnetic field, these things experience force. All magnets are surrounded by magnetic fields. The shape of magnetic field can be shown by iron fillings or plotting compasses. See, the iron fillings are sprinkled around this magnet, bar magnet, and the direction, iron fillings only show the pattern. They don't indicate the direction of field. Direction of field can be known by using plotting compass. So magnetic field around a bar magnet, it originates from north and ends at south. Actually, the magnetic field is always in the form of a loop. So what will happen when this field enters south? It will go inside the bar magnet towards north. So this will always be in the form of a loop. Okay, it does not terminate here. It appears to be ending at this pole, but inside this will be going towards north. So arrow indicates the direction of force on a free to move north pole. Okay, so direction of magnetic field lines indicate the force on north pole. The stronger the magnetic field lines, the denser the magnetic field lines. Okay, the field is stronger near the poles and it is comparatively weaker away from the poles. Magnetic fields between two bar magnets. When two opposite poles are there, the field lines are originating from north and entering the south. Okay, and they will be going through this south and they will come out of the north of the other magnet. Okay, and then they may go towards the south of the first magnet on the other side. To north repel, so this is the pattern. In between we will have null point, neutral point or null point where the resultant field is 0. In the same way, two south poles also, the fields are entering because they are coming from the north poles. In between we have null point again. So direction of magnetic field lines indicate the force on north pole. So producing a uniform magnetic field. A uniform magnetic field exerts a constant force over a region. Because field lines, how do we indicate the magnetic field lines which are magnetic field which is a uniform? The field lines are parallel to each other and equally spaced. Okay, so this region is uniform field. Closer to the poles, the field lines are not equally spaced. So this is not uniform near the south or north pole. But in between, there is a region where the field lines are equally spaced. Earth's magnetic field, okay, which helps us for navigation, and it also protects us from the charged particles which enter from the outer space, that is from the galaxy or sun, and also cause from the cosmic radiations. The Earth's magnetic field is similar in shape to that of the bar magnet. You can see this is the bar magnet and this has the same pattern of the field. It is thought to be caused by electric current flowing through the molten outer core of the Earth. At the present, the field pattern is like that with the magnetic south pole situated somewhere below the northern Greenland. Induced magnetism. For inducing magnetism, you don't need to have the magnetic substance in contact with the magnet. Even if it is away, the magnetism will be induced in iron easily and other magnetic material like nickel, cobalt, and steel. Steel is a hard magnetic material, so that takes longer to be magnetized. But once it is a magnet, it will retain its magnetism. So this is an iron bar and it is brought close to a magnet. What will you observe? See, the opposite pole will be induced at the near end. See, this is the north pole of the magnet and the near end of the iron bar is induced with south and the far end has become north pole. So when it goes out of the field, it loses the magnetism. If the material is magnetically hard, it will retain its magnetism once removed from the field like steel. Certain rocks in Earth's crust, such as lodestone, have been magnetized in this way by the Earth's magnetic field. So now there are some fill in the blanks. So you have to fill up choosing the words from here. Magnetic materials are either hard or soft. Hard magnetic materials such as steel retain their magnetism once magnetized. A magnetic pole is a region where the magnetic force is greatest. Magnetic poles always occur in pairs. Like pole repel and unlike poles attract. A magnetic field is a region where magnetic force is exerted. And you remember which objects will experience the force? The moving charges, magnetic material, and a magnet. The direction of the magnetic field around a bar magnet is from north to south. So these blanks are over now. Now we start our part B, that is electromagnetism. So Hans Ørsted in 1820 noticed that wire carrying an electric current caused a compass needle to deflect. Okay, so this is without a current, the compass needle is pointing out geographical north. Okay, but when the current is there, the magnetic field is different. The compass needle is deflected, and it indicates the field due to the wire through which current is flowing. Magnetic field pattern around the wires. So we have now straight wire. The straight wire current is downward, so field is clockwise. Okay, it is concentric circles centered on the wire. Near the wire, the field is stronger. Away from the wire, since the spacing is increased, it means field is weaker. The magnetic field is strongest near the wire. And this is shown by the field lines being closest towards or together near the wire. The strength of the field increases if the electric current is increased. Larger current means more magnetism. So there will be more field lines. So how will you find out the direction of field line around a wire through which current is flowing? We use our right hand. So we hold the wire in our right hand and the thumb indicates the direction of current and fingers are curled around the wire showing the field. So current is upward, so field is anti-clockwise. Grip the wire with the right hand. The thumb is placed in the direction of the electric current. The fingers show the direction of circular field. So when the current is downward, field will be clockwise. Now here you have to complete the diagrams. You should remember that cross in a circle shows current into the paper. Okay, you have to show current into the paper. You have to tell the field direction. Okay, when current is into the paper, using your right hand, it means thumb has to be pointed towards the paper, that is towards the screen of your computer. So the current will be shown here. Let us see. So when we use our right hand and we point out the thumb towards the laptop screen or computer screen, the fingers will be curled around wire showing the field. So this is clockwise. Second one, the field lines are given, but the current direction is not given. So you can hold the wire in your right hand in the field direction. Your finger should be in the field direction, so thumb will be outward. For outward, we show dot. Dot in a circle shows current out of the paper. Cross in a circle shows current into the paper. So here, the field is clockwise, field is given, so current is into the paper. And here the field current was given, that was out of the paper, so field is anti-clockwise. Now flat circular coil. So this side has the current upward and this side has current downward. So current upward means field is anti-clockwise and current downward means field clockwise. But inside the coil, you can see the current due to both the sides the field due to the both the sides has the same direction, that is inward. Okay, so this is the plane view without showing the coil. Dot shows current up, cross shows current down. Okay, so the pattern should be remembered. Solenoid. Solenoid is a coil of wire carrying an electric current. So this is the coil of wire through which if the current flows, so it becomes an actually electromagnet. So the magnetic field is similar shape to that of the bar magnet. That is, one end will be north and other one will be south. And field lines in a bar magnet we have seen earlier, that is they come out of the north and enter the south pole. So this is the field pattern. Current is entering and current is leaving. There is a rule also. The strength of the field increases with the electric current, the number of turns in the coil. Now we have a rule to find out the poles of this solenoid, because solenoid becomes an electromagnet, and this also has two poles, that is north and south. So grip the coil with the right hand. This is the coil. The current direction is known to us, that is upwards. So we will hold in such a way that our fingers are in the direction of current and the thumb indicates the north pole. Okay, the fingers are placed in the direction that the electric current flows around the coil, and the thumb points out the north pole. So here, this is the second diagram. This is held in the hand of the person, and in such a way that the fingers are curled around the wire, around the coil, showing the current direction. Thumb shows north. Now here we have to complete the diagram. The current direction is known to us. So where is the north pole? So what we will do, we will hold this coil in our right hand. And in what way we will hold the coil? In such a way that the direction of current is indicated by our four fingers. All four fingers will be curled around the coil this way. So thumb shows north. Thumb stretches out to indicate north. Now here in the second diagram, you have to indicate the, you have to locate the south pole. So how will we hold it? So in this diagram, it is held from the underside of the coil. Okay, so the back side, front side has current down, so back side has current up. So that is why the four fingers are around the coil, indicating the direction of current on the back side. So thumb is showing north, so it means the other end is south. Okay, if the coiling is opposite, what will happen? The opposite poles will be formed. The next diagram, here you have to show the direction of current. North pole is shown. It means we will keep our thumb towards the north and we will hold the coil showing the current direction. So this is our north pole, thumb is showing north and four fingers are showing current direction. Okay, and here we have to add the coil. We know the pole, so according to that we will add the coil. Electromagnet consists of a current carrying coil wrapped around an iron core. So you can take a nail, wrap the wire around it and connect two ends of the wire towards to the battery. You can see the coiling is opposite at the two ends. Then only we have two poles formed at the two ends. Okay, so if this is the positive side of the battery, so it means the current is downwards here on the front side. So if the current is downward, when we hold it in our right hand, the pointed end of the nail will be north. You can check it yourselves. This is also an electromagnet. Larger current and more number of coils increase the strength of electromagnet. Now uses of electromagnet. Spray yard cranes. So in order to remove the iron materials from the scrap yard, we can use the crane, which will have electromagnet attached to them. They will bend down, pick up the iron materials, soft iron materials. And this is an electromagnet. So current is switched on. It becomes a magnet, picks up the things. When the current flows, the iron becomes strongly magnetized and so picks up the iron scraps and steel also. When the current is turned off, the iron loses the magnetism, so releases the scrap. Now, second very important use of this electromagnet, that is electric bell. So it consists of this is a switch, battery, and this is a gong, and this is hammer. So hammer, when the current is turned on by pressing the switch, the current will flow, and this electromagnet will have current flowing through it, and it will become an electromagnet, and it will attract the hammer towards it. When hammer moves forward, it hits the gong and sound is heard. But what will happen at that time? Let us see. The current is flowing and switch is closed, and the hammer is towards the gong. So when, of course, it is metal gong, so sound will be heard. But at what happened at this point? The gong was, first the hammer was in contact with the contact switch. Okay, and current could flow. But when it is released from there, because this was not a permanent contact, current was flowing. Due to flow of current, it is strongly magnetized and attracts. This is iron armature actually. This is iron attached to it. So this iron is attracted, carries the hammer along, and hammer goes and hits the gong, and contact at this point is broken. Means no more current flows. So what will happen? This is springy material, so that will return. This will bring the hammer back to its position, and what will happen? It will be in contact with the contact switch, and current again starts flowing. And what will happen as a result? The hammer, this will be electromagnet. It will attract the hammer. Why it attracts the hammer? Because there is iron piece attached to it. We call it iron armature. Okay, it will be attracted towards the electromagnet. Can you tell me which poles are formed? If you know the direction of current, that is from the positive terminal of the battery and going this way upwards on the front side and downwards on the back side. So it means when we hold this in our right hand, so this end will be north. Okay, when it is an electromagnet. Now you have to label here. Numbers are given. What is this part and everything. Here we have, instead of using bar magnet, this is solenoid. It is U-shaped magnet, and it has the poles which are formed here. So you have to label this is an electromagnet. Number 1. What is number 2? Switch. Number 3, spring, which will keep it in this contact with the contact switch, and it will bring it back after the current stops flowing. Hammer, battery, 6, soft iron armature, and 7, contact switch. What is 8? Gong. The third use of electromagnet is relay switch. So relay switch is actually, it's a very important circuit which is used when we have to turn on the smaller current first, and this smaller current in turn on the larger current. Instead of turning on the larger current directly, we use the primary circuit, this which is consists of an electromagnet. Okay, and turning the larger current on directly may be sometimes dangerous. So this is primary circuit which has only one cell, and this is switch. This is some secondary circuit which is connected to high voltage. So this is iron armature which will be attracted towards the electromagnet when the current is turned on. So when the current is turned on, what will happen? The iron armature is attracted, and this is the pivot, and this is hinge. So this is moves towards the electromagnet. It moves down and closes the switch. The switch is not closed, so the secondary circuit was not working. The primary circuit works when the switch is closed. Switch is open, no current. When we close the switch, current flows, and it attracts the iron armature. The electromagnet attracts the iron armature. And what happens? The armature moves about the pivot, and the other side moves towards the springy contact, and the high voltage circuit is turned on. it could be a street light, it could be an electric motor, okay, which can be turned on indirectly by turning on first the primary circuit in which smaller current flows. Fourth use, circuit breaker. We discussed briefly about the circuit breaker in our video of mains electricity, but the detail of circuit breaker was not explained because in that video we did not study about the electromagnet. So this also consists of electromagnet, and it functions like a fuse. Okay, when the larger current flows, it breaks the path and current stops flowing. So appliances remain safe. So here, uh, the current flows between the terminal A and B. So what will be the path of the current from A, okay, and towards the electromagnet and towards the B, point B. So when the current is small, what will happen? Which is when the current is in the limit, the contact here will remain, and the appliances will continue working. But when the current exceeds certain value, the electromagnet becomes strong enough to attract the iron armature, which is shown here. See, this is the direction of current through the coil, through the electromagnet, and through the towards the point P. Okay, so what will happen if the current is small? This electromagnet will not be very strong to attract the iron armature because this spring is very hard. It has greater spring constant. So it means electromagnet has to be strong enough to attract this armature towards it. Okay, so when current is exceeds due to any fault, what will happen? This will be strongly magnetized, and the strength will be strong enough to, the force will be strong to enough to attract the armature towards it. So what will happen as a result? Let us see. This armature moves towards the electromagnet, and here the contact breaks. When the contact breaks, the current no more flows. Current stops flowing because the armature has moved towards the electromagnet. So current stops flowing. So first we should find out the fault, and after repairing the fault, we can place the switch back. So this is the diagram of domestic circuit breakers. The blanks to fill up. A wire carrying an electric current produces a magnetic field. This field increases in strength if the current is increased. A dash is a coil of wire carrying an electric current, the solenoid. The field produced increases in strength if the number of turns in the coil is increased or if iron is placed inside. You can increase the strength of an electromagnet by using iron core because iron will be strongly magnetized. Okay, the field, all the field lines will pass through the iron, so the strength of electromagnet will increase. An electromagnet consists of a coil of a solenoid wrapped around an iron core. Iron is a soft magnetic material that loses its magnetization once the current is in the coil is switched off. Magnetism and electromagnetism, there are some questions to solve, and you may answer these questions, right? You may copy the questions in your registers, and you may uh, solve them, these questions yourselves. Okay, Allah Hafiz.